Okay, in this particular video, I will be talking about a real data set. The data set I have chosen just to show you some functions that are available in Pandas to work on real data set. The data set I've chosen as a COVID-19 data set that was available in Kaggle, and it's a real data set that contains information of victims recovered, the total number of recovered people per country, per province, the total number of died people, and the total number of reported people per date available. That data is available. Let's see the look and feel of that data in a file, just to see what kind of data we are talking about. So let's say this is our data. This is a serial number column that contains just the record number. That's a column called observation date. That's a date. That's a province or state. That's a country or region. That's last updated when the record is updated. What's the time, and how many confirmed cases were there at that date, and how many deaths at that date, and how many recovered at that date. As the date is moving on and on, you will be seeing that the number of confirmed cases and the number of recovered cases, they will be increasing. Maybe the number of deaths, they also increase. So let's see this data. Let's read that data using Pandas and do some manipulation of this data and see the look and feel of that data in Jupyter Notebook. Let's go to Jupyter Notebook and see. So first of all, I need this Pandas library. I imported that. Maybe somewhere I need this NumPy library as well. I'm also loading a scikit-learn sklearn library because I want to use impute function just to handle the missing values. It is just more powerful to use the sklearn library. That is also a data science library, a package that is particularly a machine learning library or package that actually gives a better support or a larger support of handling missing data. Although here I have used this sklearn function just for an example, but I could have used this data frame fill na function or something like so, but I'm just using that one. Okay, after importing all these, what I did is I just called pd.readcsv function and I load that data, and then I did this stuff one by one. Let's spend some time on all these commands one by one. And let's see in Jupyter Notebook what is happening. Let's go to Jupyter Notebook and actually read that file and do whatever we are doing here. So first of all, import NumPy that is already imported. Import, for example, Pandas that is also already imported. Then from sklearn.impute, import simple imputer. So let's use that, or let's do that. From sklearn.impute import simple imputer. Okay, import that because that's a new thing. We need to import that. Now read the data. For example, data frame in df. So df equals pd.read csv. There is a csv file, read csv, and it contains the path of the file. The path is located in my directory. It is located at this particular location, COVID, and the name of that is COVID_19 data. So COVID_19 data.csv. So let's read that file. The file will be read. If you just see that there is a function, let's say head, that gives the top records or the records that appear just in the very top. That's what the data file that I was showing you in Excel. It is showing just the first 5 records. I can show the first 10 records, for example, just by calling the head function in this particular way. Okay, great. Let's say I just want to remove this serial number because I think that is not required, and let's say I want to remove this particular column because that is also not required. There are multiple ways of doing that. I can call a del function on this, and I can call del function on that, but there is another way of doing that by df.drop, and in that you just give the columns that you want to drop. One column is serial number, I guess. What's the column name? That's S and no. So you want to drop that column, and then you want to drop this particular column with heading last update. So that is last update. So that is, I guess, what is there. X is 1 in place true, so X is 1 is just mentioning do that stuff with columns. In place equals true, that actually is telling that whatever this operation you are going to do, reflect the changes in this df frame. If we do not write in place true, it will do everything and return onto a temporary variable or underscore variable or whatever we are saying, but the data frame will stay unchanged. So in place true means do that changing in df variable itself. So now if we see df dot head, let's say, it will no longer be showing us the serial number column and the last updated column. What next we can do, we may want to rename this name to just date, for example, this to maybe another. Let's rename all these columns using a rename function. df.rename columns equals to, and then we have that dictionary again, in place equals true. So let's use this rename function, df.rename, let's say that, and here we have columns, if I spell right, columns, and then that is dictionary. What columns you want to change? I want to change observation date. I want to change that to simply date, let's say, and I also want to change province slash state to simply state or province, let's say, simply that. And I also want to change this country slash region to simply country. So maybe I want to change this country slash region to simply to country, 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 and I want all that should be happen in place. So in place equals true. So after that, if you run that on this particular step, and now if you see the state of df, you will get like so. Okay, these many. So date, province, country, confirmed, deaths, and so on. So this is much nicer form than earlier. Moreover, we may have a lot of missing values. Oh, one way, this date format, the date format is not in a format that Pandas internal date format. So let's convert the date format into the internal Pandas date format using two pd2 datetime function. So let's say df date equals to pd2 datetime, and convert this df date in that particular format. And now if you run this df.head, you might be seeing the date format in a different way. You see that? That's a date format that the Pandas is expecting. Now that is just showing some records. If you want to see more records, we can see those. Let's say I want to just count, or let's say, let's just describe all the data. df dot describe. There is a describe function that describe most of the statistics of the data. I mean, the total count of confirmed cases are these, the deaths are these, recovered are these many columns are there, these many values are there. The mean is that, and standard deviation is that, the minimum 25, and these are the statistics. Let's say there is another function, info, df dot info. If you call that function info, it will give us the more information about the null entries and the non-null entries and so on. For example, if you see the total number of data columns are 6, the total number of records are 6162, the date entries is always available, the province entries are only 3700 available, the rest entries are null entries. So province entries, and most of the entries are null entries, and they are there. Maybe we want to drop those, or maybe we want to impute those entries and stuff like so, but there are null entries that are available in the province column. Some of the province values are no longer available. Let's see that here. For example, this is not available, this is not available, this is not available, and that's what the real state of the data is. This is not available, this is not available, and so on. So this can happen. Okay, next what we do is we actually use this simple imputer just to impute the missing values. One way is to do that using simple imputer from sklearn. Another way is, as we already know, just df.fill na with, let's say not available, with, let's say, string, some string, not available, that's an that string. And with that, if we fill na using that, now after that we will be having all that data, the missing values will be filled according to, let's see, some missing values, because in the province there were some missing values. Now you can see, for example, let me go on, yeah, so not available, not available. We can use that, or we can use a fancy kind of thing that is available by scikit-learn and so on. Okay, after that, if you now see the information info, now you will not be seeing any null value. All the columns are there. This was not in place. So dot fill na, that is, and let's change the df with it. So this doesn't happen in place. So df, just change the df. Okay, df changes. Now if we now call the info, there is no null value anymore. Yeah, so I end this video here. In the next video I will show you this group by command to just see these kind of stuff in a more detailed way, because this particular video is getting lengthier and lengthier. I'm stopping here in this particular location. Next time I will show you the group by command in the pandas data frame, and I will show you what that does. So we will explore all that code that is written here, and we will in the upcoming videos, when we will see the plotting and matplotlib, we will be using the same data file to work more and to get more insight how this pandas and matplotlib and numpy in combination, how they can actually play a very important role in analyzing very large real data files. Okay, so I end this video here. I will start the next video right from this command, and will tell you what is happening, what is this group by command. So hope to see you in the next video. Okay, in the last video we were discussing this COVID-19 file, and we reached here, but we didn't use this sklearn imputer. We just used the fill na function of data frame. Now let's discuss this group by command, or a query in pandas that is much more visible. Let's say our goal is now, for example, if you go back to Jupyter, if you see your data df.head or all, that's a df.head, let's say 10 records. If you want to see that, there are so many records, let's just see 10. Let's say what you want to do is you want to just see how many total confirmed cases are there in each country. regardless of their date. And for example, you want to just see all the confirmed cases, all the deaths, and all the recovered cases in each country for all the dates and for all the provinces combined together. One way to do that is to write a group by command. For example, let's say df2 equals df dot group by, and in group by what you see is for what kind of columns you want to group all this data. So for example, you want to group by country, so that's your grouping. Now after grouping, what do you want to see? What kind of for example, the values you want to see, because now you're grouping. Well, after grouping, I really want to see, because date is gone. Once I group all the dates, they are grouped together, all the provinces that are grouped together. So what I really want to see is just the country. And I want to see the confirmed cases. So pick all these records, confirmed, and then I want to see deaths and recovereds, for example, if I want to, deaths, and let's say then I want to see the recovered cases, RE, and just I want group all the countries together, group all these things together, and add all the records under each country. So sum all of them, and maybe we want to reset any index if it is there. So for example, reset index, so that thing. So after this query, for example, this group by query, what will happen is this df2 will contain a summary of the data with respect to each country and the total. For example, in this particular country, the total confirmed cases are these, all the confirmed cases till now, and the deaths are these and recovered as these for this country. For each country now, each country is describing. Australia, for example, till now, Australia has total these confirmed cases, these total deaths, and these are recovered cases, and so on. So that is if we want to group all these with respect to country. What if we want to group all these with respect to country and then date, for example? So first we want to group them by country, so country, and then for each country display all the dates, and then do the same stuff. The query will stay almost the same. A group by command will stay almost the same, with one kind of let's say we want to first group by country. Once it is grouped by the country, then I want to group them by date, and now I want to see all the results in the form of I want to see the date as well. And what will happen now is for each country, its trend with respect to all the dates that will be displayed here. So let's see df2 now, df2. So if you see df2 now, you can see, for example, this particular country, it has just one record, then this country it has one record, then this country for this date has this record, for the same country another date has same record, and all the date is also sorted. I mean, now you can see all the records in a very incremental way. So that may give you a very good look and feel of what is happening, or for example, another thing, what if you want to, for example, find out all the records, you just want to find out all the records. That's df3, for which the confirmed cases, for example, the confirmed cases are more than 100. Let's find out all the records. Let's just pick all the records for which the confirmed cases are larger than 100, and let's copy all these records, just those records, in this. So if we do that, we have df3 available, and we have df3 this. I mean, these are just the records in which the confirmed cases are for sure larger than 100, just those. Yeah, so we can do, I mean, a lot of a lot of data analysis, the real data analysis, a lot more. I've just shown you a very small snapshot of what we can do with pandas on the real data set. I mean, there is a lot more that we can do with this pandas library on real data sets, on multiple data files, combining them together, joining them together, seeing their correlation, a lot of stuff. And this pandas really is a very, very fancy and very high level library, very high level package to work with data. So due to time limitations, I'm just ending this pandas here, although there is much more to explain in that. But in the next video, we will be jumping towards matplotlib. Just we will see some functions of matplotlib, and we will see very briefly how can we plot, how can we analyze data using visual graphs or stuff like so. So that sometimes this visualization of different attributes of the data give very good insight to the data. Wherever possible, if the visualization is possible, if the data dimensionality in a way or the visualization techniques are in a way that you can visualize the trends in the data, that gives you much better insight than the numbers or statistical results. But it completely depends in what situation you can visualize the data. There are situations, high dimensional data, for example, is not always visualizable. So in those cases, the statistical results or the numbers may play a more important role. But in many cases, visualization give a very good initial insight into the data, and the design process can become very, very fast if you know something about the data. Whether you get that information by visualization or by other statistics or whatever. So in the next video, I will be just explaining some very few functions of matplotlib, and then we will be exploring the same file, and we will be doing some stuff using the plots and matplotlib, and seeing the trends of death rates, seeing the trends of, we will be playing with this file a bit more using matplotlib as well. So hope to see you in the next video.